a supposed comet is catching the attention of some of the nation's most renowned scientists, as one Harvard professor is raising the theory this may actually be a piece of alien technology.
Because it has anomalies. It moves on a trajectory that is very unusual. It is aligned with the orbit of the Earth around the Sun, and it will get extremely close to the inner planets like...
Amid the silent expanse of space, where the light of billions of stars seems frozen in a single moment, through the lenses considered the two greatest eyes of humanity, the Hubble Space Telescope and the James Webb, both at once turned toward a tiny yet strange point of light racing across the solar system, and it was in that very instant that the history of cosmic observation took a turn unlike any before, because what they saw was not simply an ordinary comet, but an object named 3I Atlas, something that seemed to challenge the entirety of human knowledge accumulated over centuries. It shone brighter, moved more unusually, and carried signals that shook the entire scientific community, because if this truly was a comet, then it should not exist in the way we are seeing it. So what, in the end, is 3I Atlas? A gift from the deep reaches of the Milky Way, a message from another civilization, or a sign that the universe still holds secrets humanity has never dared to imagine? When speaking of 3I Atlas, people are not only facing a stranger in the solar system, but also a figure that goes far beyond every familiar pattern of a comet. It is the third confirmed interstellar object, after Oumuamua in 2017 and 2I Borisov in 2019. In 2025, a rare context unfolded. The Hubble Space Telescope observing invisible light and ultraviolet, while James Webb looked through deep infrared waves, two of humanity's most advanced eyes working together, tracking and analyzing the mysterious appearance of 3I Atlas. The sense of urgency grew even sharper when the numbers came in. 3I Atlas raced through space at nearly 60 kilometers per second, equivalent to more than 200,000 kilometers per hour. At such a speed, if it were a normal comet as we have always known, it could not withstand the pull of the sun's gravity and would certainly have been torn apart. Yet, in complete contradiction to that assumption, 3I Atlas did not disintegrate, but instead traced a hyperbolic trajectory, escaping entirely from the sun's gravity, a clear sign that it came from the space between the stars. More importantly, the time we had to observe 3I Atlas was extremely short, from the moment it was detected by the Atlas telescope in Chile on July 1, 2025, only a few fleeting months before it plunged into the far side of the sun. The year 2025 became a moment when humanity watched breathlessly, with each frame captured by Hubble and James Webb, but also one fraught with danger, because the moment it drew close to the sun, it would vanish into the darkness, leaving us with only the tiniest glimpse of its short-lived presence near the solar system. If this were only a normal comet, then why did the data run completely counter to theory? A comet entering the solar system should travel much more slowly, revealing a clear tail and coma, but 3I Atlas appeared only with a blurred face, a faint coma and short tail, and came from a completely different region, flying at a terrifying speed on a hyperbolic path and then vanishing at its closest point to the sun. Up to now, the scientific community is still debating. Some dismiss it as merely an interesting interstellar comet, while others, like Professor Avi Loeb from Harvard, have put forth a shocking hypothesis that it could be an extraterrestrial spacecraft, because its trajectory and speed seemed as if they were written in advance. Even more alarming, its hyperbolic orbit means that once it passes, 3I Atlas will fly away forever, and we will never have another chance to approach it again. That means every image snapped by Hubble, every spectral line analyzed by James Webb, is an invaluable moment we will never have again. Observing within such a limited window places us before a mystery that gradually reveals itself, then vanishes like a dark star. Could 3I Atlas be a cold reminder that the vast universe still hides secrets we will never be truly prepared to face? The Hubble Space Telescope is regarded as humanity's extraordinary eye, capable of capturing wavelengths from visible light to ultraviolet, recording details so faint and astonishing in the deep cosmos. That is why, when it turned directly toward 31 Atlas and detected a massive coma stretching tens of thousands of kilometers, both the scientific community and space enthusiasts alike could not take their eyes off that ghostly image. Yet the strangeness did not stop there. The alignment of the dust cloud did not follow the usual rule that a comet's tail must stretch away from the sun. Instead, the dense dust appeared to be pointing directly toward the sun, a rare phenomenon that made even seasoned experts frown, questioning whether a new physical mechanism outside all expectations had appeared. Never before has a comet displayed such behavior so clearly. According to conventional understanding, when the sun's heat melts ice, dust and gas are released, and the force from radiation along with the solar wind blows them outward, away from the sun, creating a faint, elongated tail like streaks of light in the night sky. However, with 3I Atlas, that dense, hazy cloud seemed to turn back toward the sun, opening up a mystery never before recorded. Were those dust particles simply too heavy to be blown away? Or was there an invisible force strong enough to openly break the familiar rule? One hypothesis being discussed is that the dust particles released are larger in size than usual, making them less affected by the push of sunlight and keeping their original orientation toward the star around which they formed. That seemingly simple rule of physics suddenly swelled into a perplexing riddle in the eyes of observers, sparking a thrill as viewers wondered whether we are witnessing an entirely new physical mechanism, a window opening onto cosmic laws never before documented. The seriousness here does not lie in any threat to Earth. 3I Atlas does not endanger us, but in the reality that if this truly is an abnormal phenomenon, then the entire framework of comet theory, cosmic dust, and radiation pressure may be forced to face a new challenge, compelling scientists to rewrite the pages that have long been considered fixed. Could it be that we are seeing a physical mechanism never before recorded? It is no longer just a lofty theory, but a direct challenge to modern science today. In the journey to explore 3I Atlas, we do not stop only at the hazy image of an interstellar comet, but go deeper inside to uncover the primal particles, like silent memories from the dawn of the universe. And standing at the center of this stage is James Webb, the space telescope with deep infrared vision unmatched by anything else, an indispensable figure. Webb was chosen not for decoration, but because it can see through cosmic dust, detecting frozen water, silicates carrying organic molecules, even compounds that the human eye and the Hubble telescope could never touch. Spectral data obtained from recent observations revealed something that stunned the scientific community. 3I Atlas is not merely a drifting block of ice, but contains a mixture of frozen water, silicates, organic compounds, and possibly ingredients that existed even before the sun itself was born. Specifically, spectral analysis showed that the reflective composition of 3I Atlas could be modeled as 30% water ice and 70% material similar to the Tagish Lake meteorite, containing silicates rich in organics and carbon. This is not just a number, but a cold testimony that the matter inside may be more than 7 billion years old, older than our own solar system. The moment this realization came, the seriousness did not stem merely from the rarity of an interstellar object, but from the fact that for the first time, humanity had the chance to see with its own eyes the primordial traces of another star system, traces that had never dissolved with the flow of time. Webb pulled back the cosmic veil to reveal an ancient treasure, stirring in us a restless sense of the stories the universe has never told, events that happened long before the sun's light first shone upon any protoplanetary disk billions of years ago. And then a strange twist appeared. If the material in 3I Atlas truly came from another star, could it be something like a memory capsule of the universe? That is, not simply a fragment, a non-voluminous shard, but a carrier of the story of a young planet, a collapsed star system, or simply a past frozen and preserved for billions of years. Until now, we have been familiar with the image of comets as cold ghosts of planets in our system. But 3I Atlas is completely different. It seems to carry the soul of another universe, locked away in layers of ice and dust, only now slightly opening for humanity to glimpse. Considering the gravity of this moment, if the data recorded by Webb and other telescopes is valid, then not only is a piece of cosmic theory being challenged, it could force us to rewrite the history of planetary formation, the history of material transformation in stellar disks. Like a primordial physical archive long preserved, this capsule is telling us things that current theories of planetary evolution are not yet strong enough to contain. And the question raised is no longer what is primal material, but where did this composition come from, and what secret of the primordial universe does it reveal? As Hubble and James Webb continued to capture images of 3I Atlas, what made the scientific community's heart skip a beat was the striking inconsistency between the comet's brilliant coma and the actual size of its nucleus. Surrounded by a dazzling cloud of dust, the light radiated so intensely that anyone would assume it was a massive comet. But in reality, the nucleus, the very heart of the mystery, was far too modest compared to what the naked eye would imagine. Based on calculations from Hubble's images, the effective radius of the nucleus could be smaller than 2.8 kilometers if we assume it reflects only a minimum of 4% of sunlight, a number that left people stunned by the smallness of the main character hidden inside such a grand halo of light. If it were merely reflecting sunlight, then to appear that bright, the nucleus of 3I Atlas would have to be many times larger than what calculations indicate, something unsupported by Hubble's frame-by-frame images or any other telescope's observations. On the contrary, a Harvard professor, Avi Loeb, raised a shocking point. What if that brightness does not come solely from evaporating ice, but from another mechanism, a source of light originating from the nucleus of 3I Atlas itself? He argued that spectral analysis of the images showed the brightest part was not the coma alone, but the nucleus region, suggesting that the light may be emitted from within, not simply reflected sunlight. If this brightness truly does not come only from sunlight acting on ice, then the unavoidable question echoes. If this light does not come only from evaporating ice, then where does it come from? The young feel curious, the old feel uneasy, because if it is not reflection, then what lies inside the nucleus could be radioactive energy, or even something that shakes the very foundations of scientific thought, a source of artificial power like a nuclear engine. Loeb did not shy away from suggesting the provocative hypothesis 3I Atlas could be an object carrying an artificial device from another civilization, though he also admitted that more evidence is needed to confirm such an idea. More importantly, this hypothesis does not remain only on paper. If true, we are standing before one of the most game-changing discoveries, an interstellar comet behaving in ways inexplicable by modern physics, demanding that a new page be written for theory, and possibly shaking the very definition of an astronomical comet. A sense of unease mixed with fascination spreads through the minds of viewers as they ask themselves, have we just touched a sign of extraterrestrial life, or is this simply a strange natural phenomenon never before seen? Thus, this part of the story is not merely describing an event, but placing the audience before a clear crossroads. Remain loyal to the ordinary comet hypothesis, or accept that the universe has just opened a new door into the unknown, a place where there may be a new physical mechanism, or something imprinted with the mark of a distant intelligence. That is precisely the power of the mystery that 3I Atlas brings with it. In the vast expanse dotted with distant stars, 3I Atlas is not just an unexpected visitor from another sky, but a wandering star traveling along a priority traffic lane, almost perfectly aligned with the plane on which the planets of the solar system orbit, the ecliptic plane, deviating by only about 5 degrees, a path so rare it left many astronomers astonished. A study published by Loeb and his colleagues pointed out that the probability of an interstellar object randomly passing through such a narrow corridor is only 0.2%, meaning that only about 2 in 1,000 random passes would ever line up this way. What makes it even stranger is that the orbit of 3I Atlas not only slipped into the ecliptic plane, but also passed close to several major planets such as Venus, Mars, and even Jupiter, in a trajectory through the solar system that researchers calculated to have a combined probability of only about 0.005%, 1 in 20,000. Imagine a cosmic rock flying past and landing exactly in the tiny gap between millions of strands of hay, an event even less likely than that. This comparison is not just an image to portray how extraordinarily rare that orbit is, but also opens up a bitter question. Were those lines truly random, or were they arranged? For if the alignment goes beyond coincidence, it hints at the possibility of an invisible hand steering 3I Atlas along this precise path, a route straight into the center of the solar system mapped onto the very chart humanity is studying. Of course, such an idea is not idle speculation. Loeb, the astrophysicist from Harvard, once published that the orbit could not only optimize observation of the solar system from an almost hidden vantage point, but also serve as the ideal path for a probe controlled by an extraterrestrial intelligence, ETI, to harness the sun's gravity, executing an optimal braking maneuver, known as the reverse solar Oberth maneuver, aimed at the dark side of Earth's observational reach, and then continuing its journey without being promptly detected. The gravity of this possibility lies in the fact that if it cannot be explained by mere random chance, then beyond misunderstanding the nature of a rare interstellar object, we may also be overlooking the clue of a messenger from another civilization, deliberately directed into a place where humans could observe, leaving behind a hidden message or secret. And this is no longer a question confined to books, but a genuine test from the universe, forcing every viewer to frown and ask, coincidence or design? Not only does this strain the boundaries of astronomical theory, it also sparks an intense thrill in the audience's minds as they feel they are brushing against the greatest mystery modern science currently holds. And it is precisely that feeling, at once small and exhilarated before a universe that may not simply sketch randomly, that makes 3I Atlas come alive, holding viewers to the screen, because at any second the story may twist into a direction never before imagined. In the pursuit of 3I Atlas's mystery, two main hypotheses are being set forth. First, that this is a natural process never before known. Second, that the object is an intentional creation, a structure made by an extraterrestrial civilization. The storyline reaches its most urgent moment. 3I Atlas is quickly slipping into perihelion, about to disappear behind the sun where no telescope will be able to follow it further. The time to observe it remains, but not much. According to NASA and ESA, the object will reach its closest approach to the sun at the end of October 2025, around October 29th to 30th, at a point between Earth's orbit and Mars, and then continue outward, possibly lost to us forever. The tension grows because if no action is taken in time, this moment will pass like a dream one never manages to fully remember. Launching a new spacecraft to intercept 3I Atlas was ruled out from the start. The object is moving too fast and could only have been caught if a mission had been launched immediately at the time of its discovery on July 1, 2025, something beyond our technological capacity. Yet, a few desperate options are still being weighed. ESA once mentioned the JUICE spacecraft, but it was not designed to change course in that way, as its main mission remains the exploration of Jupiter's icy moons. NASA considered the Psyche spacecraft on its way to a metallic asteroid, but Psyche's trajectory does not align and its primary mission cannot be easily altered. But the option most spoken about is the proposal to use Juno, currently orbiting Jupiter, in a scientific gamble of unexpected scale. Professor Avi Loeb of Harvard proposed, if Juno's orbit could be adjusted in September 2025, then by performing a Jupiter-Oberth maneuver, the spacecraft could fly outward to approach 3I Atlas when it sweeps past Jupiter around March 2026. The press also reported Juno might use its remaining fuel to reach the fast-moving object, at least to capture images or spectral data, one single time before it slips permanently beyond reach. Of course, not everyone supports the idea. Some experts are concerned that Juno is already facing issues with its main engine, and its remaining fuel is very limited. Sending a spacecraft near the end of its life into such an unplanned mission is clearly high risk, and could even jeopardize NASA's primary objectives. Yet the supporters argue this could be a one-shot chance, a once-in-a-lifetime opportunity to touch something that could change the history of science. Not only to observe a peculiar interstellar comet, but to uncover the possibility of traces of another civilization if the hypothesis of an intentional structure is confirmed. All this creates a dramatic conflict weighing heavily on both the scientific community and the audience. Will humanity dare to risk it all, overcoming technical dangers, budgetary strains, and scheduling hurdles, just to pursue a mystery that could alter our very understanding of the universe? Perhaps the answer will be written under the faint light of Juno if it truly manages to reach that fleeting moment when 3I Atlas passes Jupiter. The race against time has never been this tense. On one side is the safety of established science, on the other is what may be called a cosmic breakthrough. Will science choose caution or step boldly into a risky journey to open a new page in the history of human understanding? In the vast ocean of the cosmos, there are moments that come only once and then vanish forever, and 3I Atlas is one of them. It is not merely a comet passing through the solar system, but possibly a primordial fragment from the earliest era of the Milky Way, carrying within it memories older than the Sun itself. As it speeds outward into the depths of space and disappears behind the Sun's blazing glow, all that will remain for humanity are a few images, a few spectral lines, and the scarce data that Hubble and James Webb managed to capture in time. Those records, seemingly just numbers, will become a priceless legacy for decades, even for generations of future scientists who will continue chasing answers to this unresolved mystery. But what unsettles us most is the open question that 3I Atlas leaves behind. If it is not just a comet, if its brightness, orbit, and primordial matter are signs of something else, then what exactly is it? A natural phenomenon never before known, or a structure bearing the imprint of extraterrestrial intelligence? That is a question only you, the viewer of this video, can answer for yourself. Share your thoughts in the comments, and don't forget to subscribe to MindGap to follow the journeys ahead, where together we uncover the greatest secrets of the universe.